In this video, we will be graphing the sine and cosine parent functions, and this is our first start with graphing sine and cosine. And all of the remaining graphing that we will do, we will compare these additional graphs to this sine and cosine parent function. So first of all, we need to understand how to make a table and how to graph and some of the properties of the sine and cosine parent function, so that we can then graph various transformations. And we'll get into more details on the transformations and the various components and how sine and cosine parent functions are specified later. For now, we're just focused on the parent function. So let's review a little bit on our unit circle. When we're graphing, and we discussed this last time, that the unit circle is important for graphing. That's one area that it's important. It's also important in solving trig equations and working with identities. So let's fill out our unit circle again. When we're graphing, we're mainly concerned with the four quadrantals. So here, the ordered pair would be 1, 0. Up here, it would be 0, 1. Over here, it would be negative 1, 0. Down here would be 0, negative 1. So those are the main areas. And then we need to fill out the angle measures in radians. We will only be graphing in radians. So this was pi over 2. This is pi. This was 3 pi over 2. And then all the way around is 2 pi, and it's also 0. So we'll put the angle measures in radians in blue and the ordered pairs in red there. So we also need to remember that cosine theta on the unit circle is equal to the x coordinate. Sine theta on the unit circle is equal to the y coordinate. So sine of pi over 2 is the y coordinate there, 1. Just to review there. Cosine of pi radians, so over here is the x coordinate, negative 1. So cosine of pi is equal to negative 1. Now that we have that established, we can start filling out our table. And like I said, we'll use the quadrantals. So we're going to use those blue, see if I can get rid of that circle. There we go. We're going to be using these blue measures for the angles. So we start with a theta value of 0, and then we go up to pi over 2 radians, and then over to pi radians, and then to 3 pi over 2 radians, and then 2 pi radians. So that'll be that'll give us one full, what is called the period of the graph, one full period, one full cycle of the graph. So we'll have the same thing here for cosine: 0, pi over 2, pi, 3 pi over 2, and 2 pi. So now we'll fill in the coordinates there. So at 0 radians, the y value is our sine value, so it's 0. Up here at pi over 2, it's 1. The y value is 1. Over here at pi, the y value is 0. 3 pi over 2 down here, the y value is negative 1. And then back around at 2 pi, we're back to a y value of 0. Now let's do cosine. So at 0, the x value is 1. Remember that cosine of theta is equal to the x coordinate on the unit circle. At pi over 2, it's 0. Over here at pi, it's negative 1. 3 pi over 2, it's 0. At 2 pi, it's 1. So now we can graph those. 0, 0 here for sine. Pi over 2 is at 1. I'm going to make this value right here 1, right here. And I'm going to make this value down here negative 1. That's my choice. It's not scaled, so I'm going to use that. So at pi over 2, it's up here at 1. At pi, it's back to 0. 3 pi over 2, it's negative 1. 2 pi, it's back to 0. So one full period of the graph looks like this, and then it would continue here. Now for cosine, so cosine is at 1 right here. We're making that 1, and this down here will be negative 1. So it's here at 1, and then at pi over 2 it's 0. At pi it's negative 1. 3 pi over 2 back to 0. 2 pi positive 1. So it would look like this. And then it would curve back down. And you can see the pattern here. We've graphed one full pattern, and if you notice, that's doing what I call the 3 M's. The 3 M's. So it's going between these values: max, middle, I'm going to abbreviate, and min. It's flowing between those. So sine starts in the middle, hits the max, down to the middle, to the min, to the middle. So it's cycling through these values. Cosine at 0 happens to start at its maximum point, its peak. It goes from the max to the middle, to the min, to the middle, to the max, and that just repeats and repeats and repeats. So if we just use that pattern, we'll be here, and then here, and then here, and then here, going backwards. We're just going between the max, the middle, and the min. Same thing here. We'll be at the middle here, be at the minimum here, we'll be at the middle here, we'll be at the maximum here. So completing this cosine graph looks like this. And once we have that pattern established, we can just continue with that pattern to continually graph the sine and cosine functions to positive and negative infinity. Now, if you look at the patterns here, you see on the cosine we start at the max, the middle, the min, the middle, the max, and that would again continue. For now, all we're worried about is filling out at least this much of the table. That gives you one full cycle, and then it's like if you took this part of the graph, all of this, to right there, and made a stamp out of it, you would be able to just stamp it backwards and forwards. So stamp it here, and then stamp it here, and it would put the cosine graph in for you. It's just repeating this cycle over and over and over again. Same thing with sine. If you took this part of the graph, one full period of it, and you made a stamp out of it, and you stamped that on your paper, it would put this part in. And then stamp it again, it would put that part on your paper. So that pattern, one full period, it just repeats over and over and over again. It's important that you recognize that specific pattern. Now, one last thing to note. The range of both of these is from -1 to 1. So our range is from -1 to 1 inclusive, -1 to 1. That's both sine and cosine. And then, so here's what I mean. The max is at 1, the min is at -1. Okay, so it's going between those. Then the other thing to notice is what I call the step, and we'll start seeing that and talk more about it when we start graphing transformations. But the step is this value here. It's going up by pi over 2 each time. It's stepping up by pi over 2, by pi over 2, by pi over 2. So in other words, if we take our radius of 1, we're at 0, then pi over 2, then pi, then 3 pi over 2, then 2 pi, and so on. So it's just stepping pi over 2, and every time we have a revolution, a full revolution here on the unit circle, it's completing a full period of our sine and cosine parent functions. And when I say that, I mean, for example, the cosine graph here, it's hitting its maximum point at 1 right here. Its y value, its function value is 1 right here. So the next time it rises up to 1, it's going to complete the full period of the graph. So this distance right here on our theta axis is what is called the period. If you look at the sine graph, for example, it's coming up through 0 here, it's coming up through 0 there, so it completes one full period when it does that. Don't get confused. It's not when it gets back to 0 right here. That's not one full period. It's going down through 0 here, it's coming up through 0 here. So if you start tracking it right here, it's coming up through 0, so you have to measure the next time it comes up through 0. So those are the basics of the sine and cosine parent functions. We'll call it good for this video, and in the next lesson we'll be doing some transformations of these graphs.